Imagine a wonderful item dissimilar to anything we've ever owned, bouncing through the immense breadth of space at multiple times the speed of the typical comet in our planetary gathering. This isn't a fabrication of science fiction, but a peculiar visitor entering our planetary gathering in 2017. This extraordinary object is the first interstellar article ever observed in our nearby planetary system, named Oumuamua, meaning a messenger from afar arriving first in Hawaiian. It has puzzled astronomers and sparked theories ranging from it being a space rock to potentially an alien spacecraft sailing through our galactic neighborhood. Oumuamua was 15 million miles from Earth, many times the distance from Earth to the Moon. What surprised scientists was its speed. As it swung around the Sun, its rate increased, defying the laws of celestial mechanics. Could it be propelled by some unknown form of cosmic radiation? Or is it a comet emitting gases in a way we've never observed before? In a universe governed by rules and conditions, Oumuamua is a mysterious exception, a vast enigma resembling a rock about 650 feet long. On October 19, 2017, a telescope in Hawaii captured a faint streak. This was no ordinary celestial body. It was Oumuamua, the first known interstellar object to visit our nearby planetary system. Unlike asteroids and comets born under the gravity of our Sun, Oumuamua was a wanderer from deep interstellar space. Its trajectory indicated that it was not bound by the Sun's gravity, making it a transient visitor to our system. What sets Oumuamua apart isn't just its origin, but also its unique characteristics. Its elongated cigar shape and rapid rotation defy the norms of typical objects in the nearby planetary system. The scientific community is buzzing with theories and discussions about the nature of Oumuamua. Is it a comet without a tail, exhibiting a strange rotation, or something entirely different? These questions have ignited extensive scientific investigation, leading to a range of hypotheses, from it being a fragment of a larger celestial body to more speculative ideas, such as it being an alien probe. The discovery of Oumuamua is a milestone in astronomy, akin to when people first looked through a telescope and realized that Earth is not the center of the universe. It sheds light on the formation of the nearby planetary system and reminds us that our planetary system is just a tiny piece of a vast, unexplored wilderness. As Oumuamua moves farther away, becoming a faint spot in the vast cosmos, the desire to study it grows. Hopefully, with advanced telescopes, we will capture more information about these interstellar messengers, offering new clues about the structure and history of the universe. Further examination of Oumuamua reveals intriguing details. Initially labeled a comet, it had none of the typical comet-like features, such as a bright coma or tail. For this reason, it was reclassified as an asteroid. However, it isn't just any asteroid. It is an elongated, cigar-shaped object unlike any asteroid we've seen before. Its unique shape has led to various theories, including the possibility that it is an alien spacecraft. Scientific papers describe the physical characteristics of Oumuamua in more detail. They note that the object is tumbling rather than rotating, which is unusual for both asteroids and comets. This tumbling motion could be the result of a collision with another planet, but this is purely speculative at this point. The trajectory of Oumuamua presents another puzzle. It entered our nearby planetary system at an unusually high speed and followed a hyperbolic path, indicating that it will never return. Most objects captured by a star's gravity enter an elliptical orbit, but not Oumuamua. According to scientists, its trajectory was influenced by non-gravitational forces, possibly due to the release of materials from rapid vaporization. However, no such gas emissions were observed, adding to the mystery. The absence of a visible coma and the object's high velocity have led to various theories. Each detail uncovered about Oumuamua adds to the enigma, prompting further investigation and speculation within the scientific community. Some researchers propose it could be a fragment of a larger object that broke apart. Others believe it might be a new class of object, neither a comet nor an asteroid. Some even entertain the possibility that Oumuamua is a solar sail driven by radiation pressure. The idea that the object's speed could make it a messenger from another star system, perhaps ejected by a planetary system orbiting a young star, suggests that Oumuamua might be one of the first observed interstellar objects. a remnant from another part of the galaxy. The story of Oumuamua is a cosmic detective tale where each piece of information only deepens the mystery. Its elongated shape is unlike anything we've seen in the planetary gathering. Could this unique shape offer benefits for interstellar travel, such as reducing drag or increasing stability? Or is it the result of some destructive event that we can't yet understand? Its trajectory adds another layer to the puzzle. The absence of a visible coma and tail rules out the possibility that outgassing influenced its path. So what non-gravitational forces are at work here? Could it be influenced by dark matter or another unknown cosmic anomaly? The theories surrounding Oumuamua range from the plausible to the fantastic. Might Oumuamua someday be a harbinger, a messenger from another star system? The likelihood that it's a solar sail is particularly intriguing, and if proven, it would revolutionize how we think about space travel, opening up the possibility of radiation-propelled ventures between stars. In exploring celestial objects like Oumuamua, astronomers rely on various tools. The investigation into the nature of Oumuamua was led by a team of researchers that included Jennifer Bergner, a physicist at the University of California, Berkeley. Bergner and her colleague Daryl Seligman, an astronomer at Cornell University, were at the forefront of unraveling the object's secrets. Their work, published in the journal Nature, is considered the most convincing model of Oumuamua's origin. According to Marco Micheli, an astronomer at the European Space Agency, the team's observations were supported by NASA's Hubble and Spitzer telescopes, which found that Oumuamua had a strangely elongated, cigar-like shape and slightly accelerated as it left the planetary system. This acceleration is often observed in comets when they are repelled by the material they emit. However, Oumuamua showed no such emission or any visible coma of dust and gas, which we would expect of a comet. The team used modeling to show that Oumuamua could have originated as a typical water comet orbiting a nearby star before being ejected from the system. High-energy cosmic rays could have converted up to 30% of the comet's water ice into hydrogen, which might have been trapped in Oumuamua's ice as it traveled through interstellar space. As it approached the Sun, the trapped hydrogen would have been released, giving the object the acceleration observed by Seligman. The team's hypothesis accounts for every peculiar aspect of Oumuamua. It suggests that Oumuamua was indeed a comet, but an unusual one. The absence of a visible coma or tail can be explained by the fact that atomic hydrogen is much less massive than the materials emitted by typical comets and thus does not entrain much dust. While Bergner and Seligman's hypothesis is convincing, it is important to note that not everyone in the scientific community is convinced. Karen Meach, an astronomer at the University of Hawaii at Manoa, still believes that a more conventional model of a comet could have occurred. She proposes that Oumuamua could simply have a small amount of dust, which would also explain the absence of a visible coma or tail. Another hypothesis, that Oumuamua could be an alien probe, has captured the public's imagination. Its elongated cigar-like shape and unusual trajectory have led to speculation that it could be an artificial object. This theory gained some traction when Avi Loeb, an astrophysicist at Harvard, suggested that Oumuamua could be a thin, flat, nearly rectangular piece of material that could be a probe sent by an advanced civilization. Loeb's hypothesis was widely reported in the media, fueling speculation. However, while the alien probe hypothesis made headlines, it has not withstood scientific scrutiny. First, if Oumuamua were a probe, it would likely have emitted some form of radiation or signals that would have been detected. Additionally, its tumbling motion is not consistent with what one would expect from a probe designed to continuously move or gather data. Moreover, the object's trajectory can be explained by natural anomalies, as discussed earlier. The hypothesis proposed by Jennifer Bergner and Daryl Seligman, which suggests that Oumuamua is a hydrogen-rich comet, accounts for its unique characteristics and does not require extraterrestrial intervention. The idea that Oumuamua could be an alien probe reflects our collective fascination with the unknown and the possibility of intelligent life beyond Earth. However, it also serves as a cautionary tale about the importance of rigorous scientific inquiry. Speculative theories, while intriguing, can divert attention from more plausible explanations. Although Oumuamua's unique characteristics have baffled astronomers, The most likely explanation is that it is an unusual type of comet or asteroid. Its long journey through interstellar space likely altered its composition, forming an outer layer that retained most of the frozen gas inside. This hypothesis accounts for its peculiar characteristics and is supported by observations from NASA's Spitzer Space Telescope. The discovery of Oumuamua has significant implications for our understanding of interstellar objects. It suggests that trillions of such objects may pass through our nearby planetary system, and we've only just begun to detect them. The Vera C. Rubin Observatory in Chile is set to receive its first engineering camera light in December 2023, with full survey operations scheduled to begin in October 2022.